Hi, I'm Mark Petrone, Deputy Commissioner of Public Works for the Town of Webster. I oversee our sewer department. Today, we'll be taking a tour of the Town of Webster Walter Bradley Water Pollution Control Facility, and joining me on this tour will be Rick Keneally, our Chief Plant Operator. During this tour, we'll be showing you the process of how we treat the raw sewage, and it's turned into water that can be discharged into Lake Ontario. We will be also showing you the age of our equipment and the condition of our equipment, some of which is 50 years old, and also the working environment that our staff works in. Along with that, we'll be discussing the transformation of this facility from a water pollution control facility to a water resource recovery facility. That transformation has many benefits to the community and the environment. It reduces greenhouse gases. It has cost avoidance. We won't be taking anything to the landfill, which right now is upwards of $500,000 a year. We'll also be creating a Class A fertilizer to be used by the community and by agriculture. So come join us and take a tour of our facility. So now we're at the head of the plant with Chief Operator Rick Keneally, and he's going to lead the tour.
Thanks, Art. And I'd like to actually touch on what Art talked about earlier in regards to this project and the needs and benefits that he addressed. But there's also potential consequences and negative effects if this project is not carried out and completed. Equipment has downtime. As we will talk about as we move along in this project and this tour, there's a lot of downtime and equipment breakage. Art spoke of the equipment being anywhere from 40 to 50 years old. It's reached its useful life. It's kind of like in your households where your furnace or your hot water tank, after a while and usage over a long period of time, it breaks down and has to be replaced, and that's kind of where we're at. And if we don't, there's potential negative effects of pumps breaking down, household backups of sewage in their basements, actually permit violations, which could be costly to the town, and negative environmental effects, specifically on Lake Ontario. So we're going to do this tour, and we're going to kind of show you how we go from what comes into the facility as influent and what goes out as effluent. The final product, it's quite the cleanup, and we will describe further on how we get to this point. I'm standing at our influent channel. Influent is the makeup of all of the flows coming from the town of Webster that needs to come through our facility and be treated before going back out to Lake Ontario. Through the town we have 22 pump stations which convey all of the sewage and influent from residents, from commercial, from industrial, commercial including restaurants, and household is really made up of your toilet water, your showers, sinks, washing machines, and garbage disposals from your kitchen sink. And all of that waste combines together and combines to approximately about 3 million gallons a day coming through our facility, which correlates to 2,100 gallons per minute of every day, all year long, that we are treating that waste. So after all of the flow reaches our facility and is through our influent channel, which we get our flow measurement from and our sampling that is done in-house at our certified lab, it now reaches our headworks building, which is the beginning of the primary treatment or pre-treatment of the waste to take out the larger objects and abrasive material. So in this building we have bar screen, conveyance equipment, and grit removal equipment. Part of the project will be to upgrade all of that equipment in here. This is our front line of defense, taking out all of the, like I said, larger material and abrasive material that causes problems down the line for equipment and maintenance issues. Being the front line of defense and a lot of the waste being taken out here, which is the inorganic waste, this equipment is down a lot, which causes that material to make its way through into the further processes. So when we do have it down a lot, our maintenance and operations staff has to work on this, but we have no isolation gates, so the flow coming into the plant still is coming through this system. So when they have to go down and work in the channels, they are standing in raw sewage with hip waders on. And that's a problem for working conditions and, you know, a safe working environment for our employees. And I think it's an obligation for the town and the community to make sure we keep this facility upgraded and updated so these employees do not have to work in those types of conditions. This upgrade will take care of that with the new equipment, with most of the mechanics and maintenance being done above ground, so they will not have to go into the channels. But if they did, we have isolation gates, so they'll be able to go into a dry channel and not stand in raw sewage. As I spoke of the downtime, a lot of this equipment and the parts are becoming obsolete because of the age of the equipment and reaching its useful life. But we are lucky to have a talented and creative staff to fabricate parts and to keep us up and running probably longer than we should be. So being the front line of defense, again, I talked about taking out the larger materials and abrasive material. As you can see here, what's coming up on our scrapers from the bar screens is a lot of material that is flushed down the toilets, which shouldn't be. And if a lot of that stuff was kept out of the sanitary system, a lot of this equipment would last longer and we would probably not need as much of it. But since that doesn't happen, and the items I'm talking about, industry says we should flush the 3 Ps: poop, pee, and toilet paper. Other than that, everything else should stay out of toilets, like flushable wipes, which really aren't flushable. They cause problems at our pump stations and at our facility here. Sanitary products, tissues, paper towels, all should be kept out of the toilets and disposed of in a different manner. These bar screens currently have wide spaces, so stuff still gets through. The new bar screens will have a lot less clearance in the bar screens and will catch a lot more of this debris, so it saves on processes and problems down the line in the system. This pipe work here, our conveyance system has had a lot of breakages, and again, I talked about our staff keeping this stuff working. We have welds that are leaking, so you have sewage and leaking out of these pipes. All of this needs to be replaced and will be in the upcoming project. So I spoke of the heavy debris and abrasive material that's taken out in our headworks building here. Here you get a good look at that. Cart is hauled out pretty much once a month. All of this material is what we consider inorganic, and this pretty much moves the majority of the inorganic out of the wastewater so we can further treat the organic material in processes down the line. So the grit that's removed is done by this, it's called a grit classifier, and it takes the grit, sends it into that container we just looked at. This has become also a maintenance intensive piece of equipment, but also not only is it needing a lot of maintenance, working on it is very difficult. As you can see in this hut, the head clearance is very low and tight to be working on for our employees. So when we upgrade this area of the plant or this piece of equipment, the storage or the hut around it will be a lot taller for our guys to work in to ease the use of maintenance. So the primary sludge that is settled in the bottom of the primary tanks is conveyed up to the solids handling building by these primary sludge pumps and these automatic valves. As you can see, they leak, and the rusted stands here, we had rusted piping, supports, we have corroded electrical equipment down in this basement. So this equipment all has to be replaced in the upcoming project. Obviously it will help us with repairs and maintenance and downtime. So now that the flow has gone through our headworks building or pre-treatment, and we've removed most all of the inorganic material of the heavy debris and abrasive material, the flow now comes into what we call primary treatment, and these are our primary clarifiers. So flow comes into these tanks and we slow the flow down and we allow mechanical means to take over. There are 3 types of treatment throughout this plant. It's mechanical treatment, biological treatment, and chemical treatment. So this is our mechanical treatment. The flow slows down, and flow through here, the water stays in here for about 2 to 4 hours. Tanks are approximately 12 feet deep. So flow comes in, and then when it slows down, it allows the heavier material and solids to settle to the bottom of the tank, and the floatables, or what we call like the greases and the oils, will rise to the top and float. And this system of paddles and chains on a slow moving sprockets and gears slowly move all of the floatables, your greases and your oils, down to one end of the tank, and then the chains and flights come back along the bottom, and they slowly pull all of your settleable and your heavy solids to this end of the tank for removal. This is called primary sludge, and this is really the real start of removing the organic material from the waste water. Organic material, if it makes it all the way through, it really causes a problem on receiving waters, because the organics will continue to break down with the bacteria in the water, and then you have oxygen depletion, and you have algae blooms, and you have fish kills. So this is a real important process of taking the organics out of the wastewater. It stated that the floatables will go to that end, which is the effluent side of the tanks. So effluent is what's leaving a tank or the plant. Influent is what's coming into the tank or into the plant. We'll be replacing all of the equipment in this tank, your flights, your chains, your sprockets, your motors, your drives. We have leaking drives that we continue to have to maintain. It will replace this with all modern equipment and save downtime and equipment longevity. As I spoke of the floatables, the grease and the oils, our staff manually skims this off, and this is removed to a landfill with no further treatment. So as I stated, the flow through this slows down. The water is in here for 2 to 4 hours, and it ends up heading out of this end of the plant into our aeration tanks, our activated sludge process. But as you can see, this water is murky, it has like an opaque color to it. That is your what we call suspended solids. So we had our floatable solids and our settleable solids. This is the stuff that cannot be removed mechanically, and now it has to move on to our activated sludge process, where we remove it biologically. So we'll be transitioning to the biological treatment of the process now. Part of the upcoming project will be the replacement of these valves, which are inoperable. They're all in the open position, which is a good thing because flow gets to go through. But again, as I talked about in the headworks building, when employees have to work inside these channels and tanks, isolating flows and valves are very important for the working conditions for these employees. So when we have to work on the flights and chains in these, which often break, the sprockets are worn down, so the chains tend to jump, and this will be taken care of in the upcoming project. But we cannot isolate flow back from these tanks into those tanks. So again, another working condition that we need to fix for our staff. So as we've now transitioned from primary treatment into secondary treatment, we went from mechanical treatment to now biological treatment, because this is a living, breathing biomass made up of bacteria that are actually breaking down that suspended solids I stated in the primary tanks. That is the organic matter that they will be breaking down that we cannot do mechanically. So again, this is a biological process. This is the heart of the treatment process. These are the true workers of the plant. They need air to survive and to do their job. So as you can see the bubbles in here, we are adding air via blowers and diffusers. The current setup we have is ceramic disc diffusers that needs acid to clean them, which is very corrosive and also, not a good working condition for employees. So the new project will consist of membrane diffusers, which we clean with brushes and hoses. So we will not need to use acid clean, which will be a better working environment for our employees. All of this equipment will be gutted and brand new. All new diffusers, piping, which as you walk through here and listen, you'll hear the air leaking, which is an inefficiency and wasting of air. Plus it lessens our treatment capacity. So all of that will rectify it. We will have dissolved oxygen controls, which control the blowers off of how much oxygen is in here, which I will explain further later on. All of the piping and mechanics throughout here will be replaced with all new equipment. So these tanks are 14 feet deep and flow through here. As I stated in the primary tank is about 2 to 4 hours is the treatment time in there. Here is about 4 to 8 hours depending on flow. So now we're up to about 6 to 10 hours that this treatment process has elapsed. So this is the second part to our secondary treatment process. These are called final clarifiers or secondary clarifiers. We have now shifted back to mechanical treatment after the biological treatment process. Again, like the primary clarifiers, we slow the flow down so heavy solids can settle, and any remaining greases that might have made its way through the process are skimmed off of the top because we do not want that going out to the lake. So, but the settled sludge here is really our biomass or the biological process that's going on in our aeration system. So they are the workers doing the job. So we have to continue to keep them in the system. So we send some of them back to the aeration tank to continue to do their job and break down the organic matter. But since they are reproducing, especially a lot quicker in the warmer temperatures, we need to do inventory control and we need to waste some of those off, and that is our secondary sludge, which is sent up to the solids handling building along with the primary sludge for further treatment and final disposal in a landfill. These tanks are 12 feet deep on the sides and slope down to 14 feet deep in the middle. Another 2 to 4 hours of detention time or retention time in here. So you can see we're up to almost 16, 18 hours of treatment process from start to finish for this waste to be treated. This was part of phase 1, which was completed in 2021. So we will be doing nothing of an upgrade here in the next project, but definitely an integral part that the town of Webster was already proactive in replacing, because the old equipment, again, asset renewal was labor intensive and parts becoming obsolete. So as part of the activated sludge process with the bacteria, which is aerobic needing air, this is our blower room, which is adding the air through the diffusers into the aeration system. Very integral part and the workhorse of the aeration system. Our current situation is we have a large blower running 24/7, but have very limited control over it. Actually, if we turn it up too fast or too high of a speed, it trips out. So we're really limited on our addition of air, which limits our treatment capacity. Also, being only one speed, it lacks efficiencies, because at night when there's not a lot of flow and high strength waste coming down through the facility because people are sleeping, we are adding too much air and therefore wasting energy. And during the day, when all the loading is coming in because the businesses are open, people are awake, and a lot more waste is coming down the sanitary system, we can't add more air when it's really needed. So we're actually limiting our treatment capacity. The upgrade will give us high efficiency blowers to first of all save energy, but also through those dissolved oxygen controls, we can fluctuate the need of the blowers, which will give us less, the blowers will ramp down during the night, saving energy, and be able to ramp up during the day when treatment is needed, and increase our treatment capacity for the upcoming project where we'll be looking into take outside waste, which is a revenue generation for the facility and the town. So now that we have walked through the liquid handling side of the plant, we are now starting the solids treatment side. And as I spoke of, out of the final or secondary clarifiers, we have a secondary sludge, which is the biomass. And again, I spoke of we need to send them back to the aeration tanks, and that's done by what we call return activated sludge pumps. And they're sending the biomass back to the aeration tank to meet the food coming in and start their process of breaking down the solids and treating the wastewater. But also they are reproducing, and we need to do inventory control. So we have waste activated sludge pumps which pull sludge off of the return lines, and we send it up to the solids handling building for further treatment and final disposal, along with the primary sludge from the primary tanks. So these are called our effluent water pumps or our process water pumps. We are using these pumps to reuse some of the effluent that's leaving our facility throughout the plant for wash down water, for pump packing, and water for the pumps to cool them. It saves us money on using regular potable water, which is your drinkable water. This is considered non-potable water. With these pumps were added during phase 1, but with all the new equipment and water usage necessary with the upgrade, we're going to be adding a third pump so it can fit that need and that demand. So we spoke of mechanical treatment and biological treatment. This is where we institute chemical treatment. This is our ferric chloride storage tanks. We have 3 8,000 gallon capacity tanks. 2 of them have been taken out of service, so we're only able to utilize 1, which creates some issues at certain times. So with the upcoming project, we'll actually be taking out all of these 3 tanks. And what we've seen over historical use, we do not need this much capacity. So we're going to be downsizing to only 2 6,000, which will save us money instead of replacing 3 8,000 gallon tanks. As we stated on the ferric chloride being chemical treatment, this is the other area that we add chemical treatment in the process. This is for disinfection. This is added just after the final clarifiers, the secondary clarifiers, before it heads out our outfall and heads to Lake Ontario. The purpose of this is to kill any harmful bacteria and to control the spread of waterborne pathogens and waterborne diseases. So this is a very important step in our process. We have 2 2,400 gallon tanks here used specifically for disinfection. So before we move on to our current solids treatment facility and complex, I'd just like to touch on the proposed upgrade, asset renewal, and water resource recovery facility project. I'm standing up in the area that the new solids handling building will be. It'll cover most of this area up here and actually into where this old trickling filter, which is inoperable and non-usable, that will be demoed, and that will take up some of where the building is going to be too. In this building we will have new solids handling equipment, a new belt press. We'll have a sludge dryer, which will take our sludge that's currently sent to a landfill at 30% solids and dry it to a 90% solid, which is a lot lighter in weight, but also create a Class A fertilizer, which can be utilized by the local agricultural community and pretty much hopefully eliminate our sludge hauling costs, which are currently at almost $500,000. We will also have in this area a new septage receiving an outside waste receiving facility that will be able to take in septage, leachate, and high strength organic waste, which is kind of food waste, liquid food waste from food production facilities that have a great value for our digesters and create more biogas for us to utilize within the facility and offset our natural gas usage. So now we'll talk about our current solids handling facility and why there is a need for the upgrade project in regards to solids handling. As you see, this is our solids handling complex. It houses our centrifuge and belt press, which currently remove the final water from the solids and sent off for disposal. We also have 3 digesters. Currently, they're more like liquid holding tanks. There is issues with heating and mixing, which are key to anaerobic digestion, which is where a biomass or bacteria, which again, we're back to biological treatment, they break down the solids further that have been removed from the liquid train, but they do it without air. So we have the aerobic bacteria on the liquid handling side, and now we have the anaerobic bacteria, which breaks down the solids in void of air and creates methane gas, which is a renewable gas. So our current digesters, because of the inoperability of them, and we have covers that are stuck on 2 of them, which limits capacity, we will be building a brand new digester, a larger one than what we have here, where I'm standing now, which will help us increase our treatment capacity. So when we are taking in outside waste, we'll be able to treat that and open up revenue streams for us. Also create more biogas that will help offset our natural gas usage for heating digesters and ancillary buildings. But we are looking to repurpose the current tanks that we have. One will become our secondary digester with gas storage. The second digester will be what we call a high strength waste holding tank, from when we're taking in this liquid waste from outsides that has high value for our digesters. It will be pumped to that tank and then fed to the digesters. And the third tank, the smaller one, will just be a swing tank for us in a wide spot if we need it for anything down the road. It's always nice to have those areas to have extra storage when needed. So speaking of heating the digesters in the building with the new renewable gas, we do have a current situation. The boiler has been out of service in this building for 2 winters now, but to put the investment into that when we are doing an upgrade, it didn't make financial sense. So we have been using temporary heat in the interim until we go through this upgrade. So here we are inside the digester and solids handling complex, where our sludge pumps to move solids between the digesters and the solids handling equipment. The issue along through here is we have gas equipment, drip traps, condensate, which takes the water out of the gas lines, but with gas lines that possibly could leak out, and we have electric gear in the same vicinity. Does not meet code anymore. It did back then, but it does not anymore. So we will clean that up, and obviously that takes care of employee safety issues and makes for a safer working environment. So this is our boiler for the digesters. This also is a piece of equipment that's reached its useful life and has become maintenance intensive, and will be replaced in the upcoming project, and will allow more efficient heating and for our digesters, which are very important to treatment and gas production. So as we touch on the need for this upgrade and asset renewal, we talk about useful life of equipment, downtime, and what that causes to our operation. But we also talk highly about employee safety and working conditions. So this is our centrifuge discharge, which is called centrate. Dumping out onto the floor, and work has to be done down here sometimes while the centrifuge is running. This is because we have collapsed drain lines. In the upcoming project, we'll be taking the centrifuge and moving it up to the new solids handling building, and all of this will be taken care of, and employees will not have to work in this unhealthy and not a very nice working condition. So again, this is our centrifuge, which is processing our solids currently. As you can hear, it's very loud, so there's a noise issue with this. It's very energy intensive. So with the upcoming project, we are switching back to the newer technology of this belt press, which will use a lot less energy and a lot more quiet. Speaking of belt presses, if we lose our centrifuge, we do not have a backup to process our solids, which would mean we would have to haul liquid sludge, and that could go up to anywhere close to $10,000 a day until we would be up and running with the centrifuge again, which again, lead time on parts is very long these days. So again, this belt press is inoperable. We have tried to run it, but all of the rollers are out of round, the pistons don't work, and as you can see in the picture, when we try to run it, we just lose solids all over the ground, and there really is no removal of solids other than by employee and shovels. So the new project will give us backup and redundancy for processing solids for those worst case scenarios. So this is called our GBT, which is a gravity belt thickener. It is a process, a very important process, removing more of the water before this sludge goes to the digester, which actually increases digester capacity for us. So as part of the upcoming project, it will be a tear down of this equipment down to the frame with all new belts, scrapers, rollers, a whole new system, controls, but the framework will stay. So currently, as you can see by Dwayne, who is monitoring this, we cannot leave it. It needs to be babysat because tracking does not work, rollers are out of round, and the new rehab GBT will have controls that we can set it, and the employee can go and work in another part of the facility and not have to babysit this equipment. Because if we leave it alone now, a huge mess could be created if the belts go offline and do not track correctly. And as you can see by the drain of the GBT, the amount of water that's being removed from the solids, all of that water would be taking up unnecessary space in the digester. So this is a very efficient process for us to remove water and save room in the digesters, which increases our capacity. So behind me is the cart where the biosolids from our solids handling facility is dumped into and will be hauled out of here on a daily basis for landfill disposal. Landfill costs have shot up, actually over doubled in the last 3 years, and landfills are closing, so it kind of limits us on our options. So really this was one of the driving forces of this project, the upgrade project, is to kind of control our economic future and sustainability, and create a Class A fertilizer instead of this biosolid that can only be used as landfill cover. As you can see, this is 30% solids, which means that's 70% moisture. It's very squeezable, and in just the consistency of it, you can see there's still a lot of water in it. And when we haul this out and pay by the ton, water weighs a lot and creates a high expenditure for us. So moving forward with the upcoming project, we'll be producing this. And just a comparison, so we haul this out, the current situation, once a day with the reduced volume, because we'll be going to 90% solids, so that's only 10% water, and a huge reduction in solids. We'll probably be hauling once a week instead if it was still going to a landfill. That's not our end goal. Our end goal is to create a sustainable fertilizer, high in nutrients for the local agricultural community to utilize. And as you can see by this has more consistency of like dirt, or like I like to compare it to is Oreo cookie crumbs that you would put on your ice cream. I don't recommend that. But obviously we'll be creating a sustainable product that can be reused. And this is a key factor in us transforming from a water pollution control facility to a water resource recovery facility. We're capturing the resources and reusing them and putting them back to the earth. So for water pollution control facilities or water resource recovery facilities, a nice revenue stream is taking in outside waste like septage and leachate. We have not been able to, and one of the main factors is this is our receiving area. This was originally designed just to take leachate, which has no really heavy debris, which we take out in our headworks through the bar screens, but septage does. So taking septage here, we get a lot of that debris and grit and abrasive material into these tanks, and it wreaks havoc on our pumps because those pumps weren't really installed to pump the heavier solids with the debris in it. So currently we're not taking any of this, which is limiting our revenue stream. So with the new project, with the new receiving station, all of those problems will be taken care of, and we'll open up a nice revenue stream for us and for the town.
At this point, you've had a tour of the treatment process and some of our supporting structures that shows the treatment facility, the treatment process, and how we clean the water. At this point, we'll be going into the administration building, which houses our office staff, our lab, our locker room, break room, and our shop. We're now in some of the office space here in the admin building. This is my office. I also share this with our office administrator, Denise Jones, and it also triples as our conference space. As you can see, this room is woefully undersized, and we also have to keep numerous documents per DEC and EPA. We do not have enough space for these documents, so this leads to a very unprofessional, inefficient working environment for the department, for our citizens, and for the staff. As part of the project, we will be enlarging our office spaces and creating more storage space for important documents. So continuing on the lack of office space, Marianne does not have enough storage space for all the commercial and residential billing that she completes on a quarterly basis, and all the documents she needs to keep track of, again, for regulatory compliance. We're now in our in-house lab. During the course of a day and week, month, we need to complete numerous tests on the sewage coming in and the effluent going out. We do 90% of those labs in-house. We have a certified lab. We send 10% of those tests out to a third party. We also complete testing for the Village of Webster, which we do gain revenue from. As you can see, this lab is, again, 50 years old, looks like an old high school lab, The guys are out of space. You can see the boxes. They do their very best to keep it neat and organized, which they have to because this lab is inspected on a regular basis, but we're out of space and out of room. Also, the lab houses our SCADA system. The SCADA is a computer program that oversees the plant, and we can control pumps and so forth right from here. As part of the project upgrade, we'll be enhancing our SCADA system and controls throughout the plant, which will increase efficiency immensely. It will not completely eliminate the need to visually look at all the pumps twice a day, but we'll have much more control right from here. We're now in our break room. This break room is far too small to hold our staff of 15. Currently, our staff takes break and lunch in 3 different locations. In here, in a room in the back shop, and also in a temporary trailer we have out in the parking lot, just so the guys can have some space and some room to enjoy their lunch and break. This room is also supposed to be our training room, as you can see. Again, without the ability to have all of our staff in one room and talk through safety trainings and get feedback and so forth, it is very difficult. We do not have a spot on premises to do that, so to achieve safety trainings and even vendor trainings, we have to break groups up into 2 and 3 at a time. This will be upgraded in the new project and enlarged. We're now in the men's locker room. We have 13 male staff here at the sewer department. This locker room is far too small to hold our staff. They deserve something better, something bigger. Also, we need functional and clean showers. These showers we have are old, somewhat work. They are used unfortunately on a regular basis when our staff gets contaminated by raw sewage. The new project will give them a clean, enlarged shower, a enlarged locker room, and so they can put all of their clothes in one spot. Currently, the staff's uniforms are located in another building about 300 or 400 feet away. So they need to go into that building, get their lock, get their uniforms, bring them back here, and change for the day. This will all be rectified to give the employees a good, healthy, clean place to work. So now we're in the boiler room for our admin building. The boiler is original to the facility. It's over 50 years old, numerous repairs and downtime, and it's very inefficient. You can see the controls, or were supposed to be controls for the heating within this building. The building has really no controls. The heat is either on or off. In my office, I have to have a fan running all year long. In Mary Ann's office, our office manager, she actually has to have a heater on in the winter. So there really is no control. It's very inefficient, and we're looking to correct this in the new project. So we're going to talk a little bit more about lack of office space. This is Rick Keneally's office, our chief plant operator. As we had no more office space in the first floor, our staff built Rick an office in the shop. This is a very difficult environment for Rick to do his important work in. It is very difficult for him to hold meetings with vendors and consultants. The new project and upgrade will allow Rick to be with myself, the office administrator, office manager, and be in close proximity so we can all work professionally and efficiently. At this point, we're going to point out a few examples of the condition of the infrastructure, the building of our shop. Here you can see the bottom of these doors. This door is rotted and completely gone. It needs to be completely replaced. There are numerous examples of this throughout our facility. Another example of the deterioration of the facility is the bottom of these doors. These are actually double sliding doors that would allow us to bring an overhead crane out to pick heavy equipment pumps off of our trucks. Because this is so rotted and deteriorated, these doors do not open, and therefore we cannot use our overhead crane and are moving very, very heavy pumps in different manners that we get it done. We use other equipment, but this is the safest way to get it done, and these will be replaced and made operable. We're now at our solids building. I want to show you this door that does not close and is very difficult to open. So we cannot actually secure the facility. This door is in need of replacement and will be done with the upgrade project. One of the other things showing the state of the infrastructure here at the sewer department is weather stripping. You can see this one is falling off. We repair these items on a regular basis. These will be replaced during the project to really save on all the labor, and also it will save on energy costs as it will better seal the doors. All of these weather strippings will be removed and replaced and should be in place for a long time. So this concludes the virtual tour of the Town of Webster Walter Bradley Pollution Control Facility. Hopefully you got a good feeling of what we do here, what it does for the environment, and the state of the facility, the state of the equipment, and the environment that our staff works in. I would encourage you to sign up online for a personal tour, which will be held in May, and we'd love to see you down here and ask any questions that you have. Thank you again.